Hi guys! In this project, I explore the implementation of audio using Wise and Unreal Engine, addressing character sounds such as footsteps, breathing and dialogue, AI behavior with player interaction, vehicle audio systems, and environmental acoustics. The main character's custom functions include footsteps, breathing, and dialogue systems where the audio is implemented. The character also has the ability to possess vehicles and interact with UI interfaces. This is a character's footstep system that utilizes a while switch component and event. A line trace using a break hit result checks which physical material the actor is stepping on. This information triggers the appropriate while switch component assigned to that material. Another approach is to implement this using an enum list, where each physical material corresponds to a specific switch change. For the breathing system, I created a simple example to illustrate the concept, which can be expanded into a more complex system. For instance, using a heartbeat pulse tied to actions like walking, running, or other gameplay events. The underlying idea is similar, connecting the heart rate, in this case, the player's walking or sprinting stamina, to a wise RTPC. For the Unreal Blueprint logic, I used a looping event with a set timer by event function to trigger a par-style breathing sound event. The current stamina float parameter controls the playback speed and intensity of the breathing sound via a wise RTPC dynamically influenced by the actor's movement. A noticeable feature is that when the actor is speaking checked to a Boolean condition, stamina regenerates faster. Stamina regeneration is managed through a separate custom function called increase stamina, where the current stamina recharges at a rate 4 times faster than it decreases. This setup allows for precise control over the breathing sound's rhythm and ensures the RTPC reacts responsively to changes in the player's state. For the dialogue, I mostly used emitters, but also employed box collision to trigger wise events. The choice depends on what you want to achieve, but for this project, I preferred working with real-time float information adapted to my wise system, so emitters were my first choice. The emitters are scattered throughout the map to cover a large area for actor interaction, while the dialogue system in Wise uses sequence containers and sidechains the breathing system. The AI NPC sphere is designed to patrol or roam designated areas within the level. It can detect the player's position using pawn sensing or AI perception, responding to sight and sound cues. The AI actor plays sound effects and triggers dialogue when interacting with the player character. All of the AI sounds are occluded using the line trace by channel function and are controlled through RTPC based on custom filters in Wise. The vehicle blueprint incorporates the character's ability through custom functions to possess vehicles, along with sound transition between interior and exterior perspectives, a fuel system, and dialogue integration. The fuel error system is triggered based on spline location. It calculates the actor position and distance along the spline relative to its total length, then adjusts the RTPC value once specific conditions are met.
You will soon run out of fuel. Do you read me?
Copy that. Fuel's almost gone. I'll try my best to land in time.
Understood. Have a safe landing.
Roger that.
Furthermore, the dialogue plays at the actor's emitter location by obtaining a reference through Get actor of class. The emitter is placed along the spline, and the system checks the distance using a vector AB distance calculation between the emitter position and the ship location on the spline. The Doppler effect is configured in Wwise using attenuation settings and an RTPC that controls pitch, filters, and the audio effect bus. There are three custom functions that define the VH Doppler blueprint: vehicle spline passing, Doppler spine vehicle, and Doppler actor spline relation. The vehicle moves along a spline and continuously checks the actor's position relative to the vehicle's location. This is done again using a vector AB distance calculation along the spline, which is then passed through a map range clap node. This creates a smooth RTPC transition with value ranging from 0 to 10 based on the distance between the actor and the vehicle. For the environmental ambiances, I created transitions using RTPC and Y switches. This includes basic sound occlusion, reverb zones, and audio portals to simulate realistic indoor and outdoor acoustics. Thanks for watching.